into a spaceship and just kept going forever, would you eventually hit a wall, a boundary, or would space just keep on going forever? This right here is Earth. Here's the sun, and here's Pluto, and here is our wormhole. For the past 46 years, Voyager 1 has been traveling through space, stopping at Jupiter and then Saturn, and then continuing its interstellar voyage in 2012. We are still receiving data from Voyager 1. And out of these 10 markers, where do you think Voyager 1 is today? After roughly 46 years, it has reached here. Yeah, we aren't even to our wormhole yet. And it won't even really make it there. Kind of. It will reach our wormhole, but not before it stops communicating with us. In a few short years, around 17 billion miles away from Earth, it will stop communicating with Earth, but it will continue to float on practically forever, potentially lasting billions of years. So let's say you were on this ship and had a device that could put you into a coma for 10 years, only waking you up for one day to celebrate each new decade. And then you go back to sleep. Your path would cross our wormhole while you're asleep in the year 2117, probably around February. By that point, you have traveled well over 46 billion miles away from Earth. But what if you just kept going? See, inside Voyager 1, you're traveling at about 38,000 miles per hour. And if you were going around the Earth at that rate, you could travel around the Earth 1.5 times per hour. Think about that. If you were hovering over China and then ordered pizza in New York, 45 minutes later, you could be in New York eating your pizza. That is very quick for Earth. But if you kept waking up once every 10 years, traveling at 38,000 miles per hour, you would have to wake up 1,752 more times before you reach 1 light year. And remember, you only wake up once every 10 years. So that would be 17,520 years from now. You would wake up in the year 19,551, probably around February. Now, obviously you'd be dead by this point, but let's assume this device kept you alive. During which, if you woke up once every 10 years again, but only aged during the one day that you were alive, you would have aged 5 years. And that's only aging one day every 10 years. By the time you reach Alpha Centauri, the solar system closest to ours, you will have been traveling for 74,289 years. But here's the problem. We actually currently have the ability to travel over 10 times the rate of that speed with the Parker Space Probe. But that's kind of cheating. First, just like Voyager 1, it's unmanned. And second, it uses gravity to help its propulsion. But surely by the year 76,000-ish, we will have made a spaceship that could go way faster than either of these two, right? Possibly by that point even overtaking our current position. So when is the optimal time to launch a spacecraft so that it doesn't get beaten by your future selves? This is called the incessant obsolescence pulse state. Could we potentially design a ship by the year, say, 30,000 that could be at the same space you are in the year 76,000? The answer is almost certainly, assuming we don't kill each other. But let's not worry about that. Let's keep you on Voyager 1 and just keep traveling to the furthest known place in our universe. Welcome to Jade's GS-Z 14-0. but for simplicity, we're just gonna go on calling it Jades. To get to the next solar system, Alpha Centauri, waking up only one day out of every 10 years, and only aging that singular day every 10th year, you would have aged about 20 years. You would be about 20 years older than when you first started your journey. But by the time you reach Jades, we will likely have not been keeping track of years the way we do now for a very long time. Even if we did, you likely wouldn't say this number in its completion. You would have some abbreviation for how you say it, like how we say back in 99. But humans would likely be dead. Actually, the scientists who estimate the age of the universe today would be way closer to the start of the universe than they would be to us. By the time you traveled to Jades, even if you woke up only one day every millionth year, you wouldn't have made it 0.5% of your journey by the time you turn 100 years old. Remember, we're only aging on the days we're awake, and you're only aging one day every million years. And this again wouldn't make you even 0.5% of the way there. Welcome to the rounded down year of 238 trillion. If you made it to the edge of the known universe today, inside of Voyager 1, you would have experienced what the entire universe has experienced in its time thus far 18,307 times over. So if you think the universe is old now, that's nothing. But sometimes when you say 238 trillion, it just kind of rolls off the tongue and you don't know what it means. So let's put this number into perspective. If you were to be able to destroy a grain of sand once every second during your travel time to Jades, how many grains of sand would be left on Earth? Okay, that was a trick question. You would have ran out of sand a long time ago. But like, what if every 5 seconds you moved one grain of sand from Earth to space? And then once you're done with that, moved those grains of sand in space back to Earth. Well, I hate to break it to you, but you still wouldn't have made it even 1% of your journey. Okay, let's really ramp this up. Every minute, let's move 3 grains of sand, or 1 grain of sand every 20 seconds, from Earth to space. And then let's move them back. But this time, instead of moving 3 grains of sand every minute, let's only move 1 grain of sand every minute. By the time you've put all the sand into space, and then all the sand back on Earth, surely we would be at Jades by then. Nope. In order to do this effectively and take up as much time as we could, we'd have to move 1 grain of sand every 100 seconds to outer space and then back. Now do each of those trips 4 more times. And then you'd still have, give or take, a couple hundred years left. But now we get to, why have we even been traveling the known creation? Why is it we spent 238 trillion years to get here? Would we have discovered more by that point? Probably yes. But let's assume Jades is the edge of the universe. Science tells us that while Earth is round, the universe has never appeared to be so. So does the universe just continue on infinitely? If it does that mean there's another you traveling for another 238 trillion years? But instead of having brown eyes, maybe he has blue eyes. According to math, yes. But if the universe really is infinite, we would never, ever see him. Never mind the fact that by 238 trillion years, we would have already been dead for almost all of that. But if there was just like a wall, kind of like in Narnia, where you just end up at the edge, what would we do? Well, Okay, you'd probably crash. But who knows, you've been traveling somehow for 238 trillion years and you're still alive then, so maybe you've got some tricks up your sleeve. But let's just pause for a minute, because I've kind of been lying to you. See, you wouldn't be at Jade's by this point, not even close. By this point, 238 trillion years from now, the universe would have kept expanding at an insane rate. Jade's would be further then than you are to Jade's right now. Even after traveling at 38,000 miles per hour for 238 trillion years, Jade's would be further then than you are right now. A lot further. In fact, you're likely never getting there. See, you're gonna be losing ground to the universe at a near 200,000 miles per hour. If you were to reach Jade, spoiler, you still can't, you'd certainly never reach the end of the universe. Even if there was one, you're just simply not traveling at a high enough velocity. In fact, everything is relative. And relative to the universe, you've practically stayed where you are. So let's just set our sights on Jade's instead of the edge of the universe. Currently, you'd have to travel at the speed of light for 13.1 billion years to get there. And that's assuming it hasn't gotten further away by the time you do get there. But will we ever get to somewhere like Alpha Centauri? In short, not today, and probably not soon. We would have to build something that could sustain life on it for several years. And yes, we have had people stay in space for almost a year and a half back in 1995 to study the long-term effects that space has on a person. But that's on the space station, which is resupplied every 45 to 50 days. A ship traveling without resupplies or limited resupplies would at least need to make it 2 years before they got resupplied. This would work by sending a slower, bigger ship ahead, and then a couple years later sending a smaller, faster, more agile ship to catch up with the bigger ship, which by this point would have certainly dwindled down its supplies almost completely. But assuming a ship of that size would even work, it would travel at a rate a lot slower than Voyager 1. Even if it could supply itself for enough time, it would have to travel at least half the speed of light in order for this to be even somewhat feasible. And we still wouldn't reach Alpha Centauri until at least 10 years from now. In order to do that, we would actually still need to send several resupply ships that would have to travel faster than half the speed of light to catch back up to it. The more supplies on the ship, the less potential speed or fuel it might have. But the less supplies available, the more resupplies it would have to have. No ship is anywhere near close enough in technology to reach Alpha Centauri. And the main problem is fuel. But what would be a proper alternate fuel? If we theoretically needed to reach Alpha Centauri in the fastest time possible, we would need an ABCAP, or in other words, an advanced beam core antimatter propulsion. Estimated to go about 70% the speed of light, it would get us down from our Voyager 1's estimated 74,000 years to a mere 5 years. While theoretically possible, this unfortunately is not feasible. Humanity has only created a few nanograms of antimatter, and just getting somewhere like Mars would take millions of times more than we have 75 years into the process of making antimatter. A more practical goal would be to get something that gets us to, say, around 20% the speed of light, which would make us wait 22 years to get to Alpha Centauri. But this is actually much more in grasp, like, say, using a light sail. Artemis 2 was a great achievement, but to go any further in a manned spaceship is going to take a lot of math, physics, engineering, and time. It is almost certain we will not see anything like Alpha Centauri in our lifetime. And it is unlikely we would ever even see the beginning of one of these missions. But hey, who knows? Sometimes necessity breeds brilliance. But let's tackle a man on Mars first. Who knows what the universe really has out there? And is it even really ours to explore? I don't know. Maybe a wormhole is our best bet. I'm Lincoln, and it's just hypothetical.